Okay, making sure my view, yeah. We are continuing to work with the distributive property and combining like terms because the two things go together. So our standard is to apply the properties that we've talked about: identity, inverse, commutative, associative, to create equivalent linear expressions, including situations that involve factoring. So given 2x times 1, we're going to realize that that's the same as 2 times x minus 5. Justify each step in the process. So today we're just going to simplify by combining like terms and by applying the distributive property through the process. Like terms are terms that have the same variable or no variable. The terms with no variable is called a constant. Take a minute, push pause, make sure you've got that typed or written. Expression is well, let's Google it because I don't really like what I'm going to say. But the thing that I look for is it's a list, a combination of numbers with variables, constants, etc. Not really. Does not have an equal sign. So an example of that would be something like 2x plus 5 plus 3x plus, or minus 4. That is an expression. It has no equal sign, but it has all of those numbers, coefficients, constants, so that makes it an expression. It is not an equation because it doesn't have an equal. Distributive property. I'm going to pause and make sure that I Google that and use the correct definition. All right, we're going to get it fresh from Google. Our definition. The distributive property tells us how to solve expressions in the form of A times the quantity B plus C. The distributive property is sometimes called the distributive law of multiplication and division. Push pause, make sure you have it written or typed, and make sure that you understand it. Variable is a letter representation of a number or sometimes a set of numbers. We aren't dealing with a set of numbers right now. We're just dealing with one solution. So make sure that you have all that copied, and then we'll move on. All right, we are going to simplify by combining like terms. We have done some of this already. The first thing that we're going to do is bring down all of the like terms. So the 20x comes first. Then it looks like there's another plus 6x. Oh. And then minus 8x. So I brought all the x's with their operations down. I'm going to bring down my constants, which is the numbers that do not have the variable. And then plus 19. Now that I have done that, I can combine my like terms. So I'm going to combine all of these first, and then I will combine all of these. So hopefully it will let me do that. 20 plus 6 is 26, minus 8 is 18. So when I put all of those x's together, all I'm going to end up with 18x. When I put the 5 and the 19 together, I end up with 24. Let's see if I can make that match so that you see where it comes from. And that's how that works. Okay, Same thing here. You are going to bring down, assuming this lets me, your letters, your numbers with coefficients. So 30m minus 9m, that is 0, 9m, and it has an n as well, so that's not right. Plus 7m, and then there's the n minus a 9n. Now I bring down the other ones that do not have any variables, which is my constants, plus 15 minus 10. And you are going to combine those as well. So let's see if I can make some color coding for you so that you see 9 does not have any other common terms. Let's see. Okay. And now I'm just going to add them. 30m and 7 more m's makes 37m. The 9 stays the same. The 9n just stays 9n. And then your 15 minus 10 will end up being plus 5. Okay, we'll continue moving on with number 3. I'm going to rewrite, make sure that I don't miss any. Alphabetical order, my negative 9h starts. I have a positive 9h later, so I'm bringing it down. Then I have my k, H-I-J-K, so 7k plus 11k, and I only have one constant, which is 22. I'm going to continue to combine my like terms, and it looks as if 9 minus 9, I have no h's left, but when I combine my k's, I will have, that is not a pretty, I will have 18k. And 1 minus 22, it has nothing to combine with. Continuing to do this, I'm going to do it and let you guys try it on your own, then come back and see if you got it right. No. Okay, I have rewritten it, and I want you to notice that I did put it in alphabetical order, because that is something that mathematicians make sure that they write it in alphabetical order. So I put my R first, then I put the S, the one S that I have, then the T's go together. So if you say the alphabet, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. So now that I've done that, I will just combine my terms. 30 minus 20 is 10 R's. The minus 16 are S's. Do not have any other terms that are like it, so I just bring it down. 24t minus 12t's means that I have 12t's left over, and the sad little 28 by itself. So there's the answer to that one. We will continue on with the distributive property. If you recall correctly, we are working to show our work so that 4 has to be distributed to every number in there. So 4 has to go with the 3x, but it also has to go, the 4 also has to go with the 5. And I'm going to make sure that's a minus like it's supposed to be. Once you've done that, you simply do your multiplication. 4 times 3 is 12, x, and you bring your minus. 4 times 5 is 20. So these are very similar to what we've been doing in the other classes, or the earlier. We've already been doing some of this. So I'm just kind of making sure that you guys know what you're doing. I'm going to go ahead and do these other problems. You guys try them, then come back and see if you got them right. All right, these are the answers that I came up with for solving distributive properties. Again, we have done some of those before, so I want to make sure that you guys have that fresh in your brain. We will do part 2 of this maybe today, maybe tomorrow, depends on where we are in our teaching.